So one of the things you might be asked to do in working with material section 10.1 is find some square roots, or excuse me, find some values of some quotients involving a square root. Now, one thing to keep in mind is that this really represents two solutions. So the first one would be -7 plus the square root of 13 over 18. And the second one would be -7 minus the square root of 13 over 18. Now, a lot of you probably have a graphing calculator, and that's great. We'll do that next. But if you don't have a graphing calculator, one of the things you can do is use Desmos. So go to desmos.com/calculator. And you'll get something like this. Let's try putting in the expression. It's going to be -7. Actually, you know what? I'm going to need a parenthesis around this. So parenthesis, -7 plus, and if you hit that keyboard icon at the bottom left of your screen, one of the options you'll see is a square root. We want the square root of 13. Now put in a right parenthesis. Then when you hit the divide key, it divides all of that by 18. And it shows you the numerical value right here. Let me do that again for the other case. Remember that there was two cases here. There was a +1 and a -1. So let me repeat that for that second case. So once again, you start out with a parenthesis, -7. This time I want a minus square root. Somehow I put my parenthesis in there for me. Minus the square root of 13. Hit the right arrow to get out from underneath the square root, right parenthesis, and then divide by 18. So we get our numbers either way. Let me show you how to do this on the graphing calculator. I'm going to copy down these numbers first, though. So -0.1885 and -0.5891. So just like that. Now, eventually the problem is going to ask you to round it to the nearest hundredth place. So we'll get to that in a second. But let me switch over to the graphing calculator. If you're going to do this on the graphing calculator, then one way to do it is kind of like what we did with Desmos. Start with a left parenthesis and then do -7 plus the square root. So second, and then the x squared key gives you the square root. Notice the square root's in blue. And the second button gives you those blue functions. Now you've got to hit the right arrow to get out from underneath the square root. And then divide by 18. Now, if you have a TI-84 or TI-83 like this, one of the things you can do is repeat some of your calculations. So I'm going to just repeat this calculation by going up twice. If you press enter, it should bring that down so that you can edit that. I'll just go back here and change that plus to a minus. So I'm getting the same thing. If you have an older TI-83, then it's probably going to look a little different. You're going to get something like this. I'll do -7 plus the square root of 13. So 13. Now here, when I hit the square root key, it doesn't form a nice square root over the number. So it's going to take the square root of everything it sees until you put in that right parenthesis. Now that right parenthesis just closes off the square root. So to finish off the numerator, I need another right parenthesis, and then divided by 18. And I don't want to belabor this too much, but if you have a nice up-to-date TI-84, there's one last possibility. If you hit the alpha key here, not the second key, but the alpha key, alpha y equals, rats. I got to do this in the right mode. So do it in math print. Let's try that again. Alpha and then y equals. The first option you have here is for a regular fraction, kind of the way we would write it. So in this case, I won't need parentheses. I'll just do -7 plus the square root of 13. And that's all in the numerator. Hit the down arrow to put the 18 in the denominator, and there you go. So a lot of different possibilities. Hopefully one of them works for you. Now keep in mind, these numbers go on forever, but you might be asked to round them. In this case, if we're rounding to the nearest hundredth, that'd be -0.19. What would this one round to? .5891. To the nearest hundredth place rounds to
0.60.
Not quite.
Or I'm sorry, 59.
There you go, 59. Thank you, 59. Okay, so that's just a little bit of work with things numerically. But a lot of what we're doing here is to solve quadratic equations. And an example of one would be u squared plus 28 equals 0. Now, typically for your quadratic equations, you expect two solutions. In this case, so we'll call this example B. In this case, move the 28 to this side. When it changes sides, it changes signs. Then I'll take the square root on both sides. When you take the square root, keep in mind that there's two possibilities, and we denote them with a plus or minus. Now that square root needs to be broken up a little bit, at least if you want to get the right answer. So I'm going to break it up into 3 radicals like this. You may remember our work with this kind of stuff. One of these radicals should have a -1. I'm going to make it the middle one. Now the first one is going to be a perfect square. The last one's going to be whatever is left over. What perfect square goes into 28 evenly?
4.
4. Thank you. And now we can just simplify the rest of this. How does this simplify? What's left? What do I get?
Plus or minus 2i square root of 7.
Perfect. Thank you so much.
You're welcome.
Plus or minus 2i times the square root of 7. Looking good. Any comments on that? Something that maybe I glossed over a little bit too quickly, want some more help on? Okay, let's keep going. There's a problem like this in your homework. So here's a nice example of it. And now you can use the square root property when you've just got one squared term or expression that you can isolate. And in this case, there's no term in y, it's just a term in y squared. So I can isolate that y squared term by first of all adding 16 to both sides and then dividing both sides by 7. Then I'll take the square root on both sides. But when I take the square root, you got to remember you need the plus or minus on the right-hand side. Plus or minus square root of 16 over 7. And I'm going to simplify that a little bit more. We'll do plus or minus square root of 16 divided by square root of 7. Anyone suggest a reason I did that?
16.
Yeah, 16 is a nice perfect square. So that becomes plus or minus 4 over the square root of 7. And I'd be happy to tell you that we're done. But unfortunately, we're not. We have to keep going with that. So the problem is, as mathematicians, we don't like to divide by a square root. So we're going to get rid of that square root. How are we going to get rid of that square root? Does anyone remember?
You square the whole term.
We can't exactly square.
Multiply the top and bottom by root 7.
Yeah.
There we go. So we're going to multiply by the top and bottom by the square root of 7. And that does have the effect of sort of squaring the denominator. So maybe that's what you're referring to. Because in the numerator, we're going to get 4 square roots of 7. Nothing changes there. But in the denominator, 7 times 7 is square root of 49. And square root of 49 is 7. Let's not forget our plus or minus. Whoops. Didn't realize I'd gotten off screen there a little bit. And so that's going to be the answer that WebAssign is going to be looking for, is that one right there. Now, on a face-to-face class, if you left your answer here, you'd probably lose a couple points. You're not going to lose everything. And WebAssign, if you don't give them that, you're going to lose everything. So try and be careful with those. Any comments or thoughts on that one? Let me keep rolling. Let's try x minus 5 squared equals 49. So again, you've got a nice squared expression and then something else on the right-hand side. So we can use our square root property. So we'll take the square root on both sides. The thing we got to keep in mind is that on the right-hand side, when we take the square roots, we need that plus or minus. So let's fill things in. The square root of something squared, those two operations cancel each other. In fact, let me lay the groundwork for something else later on. Those are inverse operations. What one does, the other one undoes. So they cancel each other out. I'm just left with x minus 5 equals plus or minus 7. Now this is where some people can get into trouble, because a lot of times people want to move this over and get, oh, plus or minus 12. I'm done. It's not quite that simple. You have to be a little bit more careful. What I like to suggest people do here is that they write down the two possibilities. Either x minus 5 equals positive 7 or x minus 5 equals negative 7. So all I'm doing is just really writing out what this means. There's two possibilities. Now, if you add 5 here, we get x equals 12. What happens if I add 5 here? What do I get?
-2.
Negative 2. Thank you, Christy.
Wow.
So you can't just move this over and get plus or minus 12, because that would only be half right. Yay. Now, in order to get something like this, what might have happened before you ever even saw that problem is somebody did some work on completing the square. So let me give you an example of completing the square. And since this is, supposed to work on the harder ones, let me give you a harder one. And that would be, yeah, let's see, we'll do 1/5 x plus something. This is the way I'd write it in class, and it's actually similarly written on WebAssign. So the goal is to figure out what number you would put here to get a perfect square trinomial. In other words, this, when I figure out the right number, is going to be the square of a binomial. Now, there was 2 steps in doing this. In the video, I was careful to say, multiply the middle coefficient by 1/2. So 1/2 times 1/5 gives me what?
1/10.
1/10. And then the next thing we got to do is we got to square that 1/10. 1/10 squared, 1/10 times 1/10 gives me 1/100th. Now that 1/100th term goes right here. So that one goes here. But our work here isn't wasted either. This term helps me out over here. So to fill in this blank, I'm going to put in the 1/100th. Well, how about here? What should I put in here? What do I square to get this?
It's x squared, or it's x plus 1/10.
Perfect, x plus 1/10. Now, sometimes people just want to put in the 1/10. 1/10 squared would give you this, but I wouldn't get any of this. Yeah, so perfect, thank you. You need to put in x plus 1/10 squared. Now I'll practice this again with a different example, a little bit easier here, but we're going to solve a quadratic equation this way. You'll find one problem like this in the homework. You know, if you get it, great. If not, that's okay. There's other ways we can solve these problems that we'll work on after the break. Are we okay with this one? All right. Let me give you one last problem here. So example F, x squared minus 18x plus 2 equals 0. Now, the first thing you should look for when you do these types of problems is, can it factor? If it can factor, hey, factor it, solve it, be done with it. That's great. But if it doesn't factor, then you need to do something else. And one of the other possibilities would be to complete the square. Now, I'm just using this mostly as an example of completing the square. But like I say, you do have one where you're asked to solve by completing the square, and this would be it. When I move that 2 to the right-hand side, it changes signs, so it's also going to changes sides, it's going to change signs. Now the trick is, here, I want to come up with a number that makes this a perfect square. I want to write this as something squared on the left-hand side. I want that whole thing to be a perfect square. So what number do I put there to make that a perfect square? No takers?
36.
You're probably in the right direction.
The negative
It's
9
negative
squared.
18.
Negative 18. So that'd be half of that would be what?
9.
Negative 9. And what do I do with that negative 9?
Square it.
You square it.
81.
Good. Negative 9 squared is 81. So I'm getting two numbers out of this process. That 81 goes right there. So I'll add 81 to both sides of this problem. So I'll add 81 here and 81 here. All I did on the left-hand side was I completed the square. And because I added 81 to the left-hand side, being a fair-minded guy, I also added 81 to the right-hand side. So this is just completing the square like we worked on in example E. Now I'll save you the trouble of calculating this on your calculator. That's going to give me 79. But the left-hand side now is a perfect square. What do I square to get that? Come on, make me look good.
X minus 9.
Thank you. X minus 9. It's a perfect square. So when you do this process of completing the square, you actually end up using both of these numbers. This one goes here to complete the square. This one is part of the binomial that you squared to get this one. So thank you for the help. X minus 9 squared equals 79. This is a perfect square. So let's solve this by making the square root on both sides. And I get X minus 9 equals plus or minus the square root of 79. Square root of 79 is not going to simplify at all. In fact, I think 79 is a prime number, but I'm not 100% sure. If you move the 9 to the other side, it's going to change signs. So I'll end up with 9 plus or minus the square root of 79. So you get two solutions. You might be asked to write them out as 9 plus the square root of 79 and 9 minus the square root of 79. But there's your two solutions. Awesome. Comments or thoughts on this last one? Okay, I'm going to stop the recording here and get you guys working on this stuff.